before I talk about finding the domain of rational function involving common and natural logarithm, I would like to review the domain and range and the graph of common and natural logarithm. So there are two graphs on the left. The first one is for Ln, the second one is for common logarithm. I would just call that LOG. So for Ln and LOG, they are both increasing function. So do you see that there is a purple dashed line? So that is called vertical asymptote. So both Ln and Log, they have a vertical asymptote at the y-axis, which is x equals to 0. So how do you say more words to describe this vertical asymptote? So one thing that we can say is as x approaches to 0 from the right. So what does that mean? So x approaches to 0 from the right hand side. So starting on the right hand side, follow my cursor. So we are approaching the vertical asymptote from the right hand side. As we are getting closer and closer, what happened to the y value? The y goes all the way down, right? So that means as x approaches to 0 from the right, y goes all the way down, means y approaches to negative infinity. Alright, so that is what the vertical asymptote is. And then what else do you see? For the Ln and the Log, they are both increasing function, right? So there is one x-intercept when x is equals to 1, y is equals to 0, and then the domain is x greater than 0. How come x cannot be equal to 0? Because for both functions, when x is equals to 0, the function is undefined, because when x is equals to 0, that is a vertical asymptote. So when x is equals to 0, nothing is defined. So x must be greater than 0, no equal. And then for the interval, we go from 0 all the way to positive infinity. When you write interval, remember you have small number on the left, followed by a comma, and then big number on the right. So look at the first two graphs. It looks like the Ln and the Log, they both have the same curve, right? But if you put them on the same graph, you will find out that they are not the same. They look the same, but they are not the same. So move on to the graph on the right. Do you see that there is an Ln in red and then the Log in blue? So they are equal to each other when x is equals to 1. So Ln1 and Log1 is equals to 0. So for Ln1, so we can do a quick math right here. So Ln1, what is that equal to? So I said that equals to 0, right? But why? So what is the base of Ln? The base of Ln is Le. So this is e to the 0 power equals to 1. I just write this from exponential form, from logarithmic form to exponential form. So e raised to the 0 power is equals to 1. E is approximately equals to 2.7. So 2.7 raised to the 0 power is equals to 1. And then the other one, so log of 1 is equals to 0. Why? Because for log, the base is 10. 10 raised to the 0 power is equals to 1. So that's why these two curves, they are equal to each other when x is equals to 1. And that is also the x-intercept. And then the range for Ln and Log. So do you see that x can be equal to 0? Right? Y can be equal to 0. Y can be greater than 0 and less than 0. So when y is equals to 0, we have the x-intercept, right? So above the x-axis, we have y greater than 0. Below the x-axis, or I should say when x is between 0 and 1, so you see that when x is between 0 and 1, the curve is below the x-axis. So when x is between 0 and 1, y is negative. So y can be positive, negative, and 0. Therefore, y can be any real number. So that is the graph of Ln and Log and their domain. So we will need that when we deal with rational function involving Ln and Log. We are going to do that right now. So allow me to take a couple seconds to move up to this page. So on this page, I have two functions, function f and function g. I would like to find the domain of these two functions. So let's start from the function f of x. So this one, we have an Ln on top. So Ln of negative x plus 12. So for the domain of Ln, everything inside the parenthesis must be greater than 0. Still remember the domain? The everything inside the ln parenthesis must be greater than 0. So negative x plus 12, just like the previous picture that I show you on the previous page, so must be greater than 0. And then you solve the inequality, subtract 12 on both sides. And then you either multiply or divide both sides by -1. Remember, for inequality, every time you multiply or divide both sides by negative, you have to reverse the direction of the inequality symbol. So the first restriction is x must be greater than 12. And then the next one is you have 2x minus 14 in the denominator. So since that is in the denominator, we have to point out that 2x minus 14 cannot be equal to 0. All right, then solve this. 2x cannot be equal to past the 14, and then x cannot be equal to divide both sides by 2. You have a 7. And then the next one, inside the square root, we have a 3x plus 7. So since square root, the square is even, right? So for square root, the 4th root, the 6th root, the 8th, the 10th, the 12th, as long as that is even, you have to say the radicand must be greater than or equal to 0. Is this totally right? The answer is no. You cannot use the equal, because once you put 3x plus 7 equals to 0, you have a 0 in the denominator. So therefore, we have to correct that to 3x plus 7 greater than only. Solve that. 3x greater than -7, and then x is greater than -7/3. So these are the 3 restrictions we have to put on the number lines, and then we draw a number line, and then we have a negative, a 7, and then a 12, right? So this is a greater than, but we make a jump at 7 because x cannot be equal to 7, and then x less than 12, so this is a 12. So that's it. That is the number line, and then the domain is from -7/3 to +7, and then from 7 to +12, right? So we do not use any square bracket because x cannot be equal to 7, 12, and -7/3. That's why there is no solid circle. All right, moving on to the function g. We have x to the 5th, so how do we take care of that? So the x to the 5th is on top. Do we need to worry about that? The answer is no. If you only consider x to the 5th itself, x can be negative, positive, 0. I don't really care, right? Because that is in the numerator. You take a number, raise that to the 5th power. Yes, you can pick whatever number you like. So the x to the 5th has no restriction. So I would just put x raised to the 5th has no restriction. How about the -3x plus 9? So then, actually, you know what? Let's change that to a +3x plus 9. So this one, I'm going to change the problem right now. So we haven't solved that yet, so that doesn't affect your notes. So I will just do 3x plus 9 greater than 0. Is this right? So again, I would like to change that to a +3. All right. So +3x plus 9. Did I forget something? This time I have the square root on top. Yes, I forgot what? I forgot an equal. Because 3x plus 9 is on top, it is okay to use an equal. Because 3x plus 9 equals to 0, so what? Then square root of 0 is equals to 0. Having a 0 in the numerator, perfectly fine. Alright, solve it. 3x greater than or equal to -9. Divide both sides by +3. We do not need to switch the sign at all, so x is greater than or equal to -3. Because you divided both sides by +3, positive, not negative. So that's why you do not reverse the direction of the inequality symbol. And then the next one, okay, here is what I'm going to do. I haven't taken care of the denominator yet, right? I know you already write it down. Apologize for that. So let me make a change right now, because I know that if I keep solving this, it will lead me to some trouble. So before I create that trouble, let's just change this. X minus 10, and then -x plus 30. So take a couple seconds. We write the function on your notes. right? So we make 3 changes. The first one is the minus. So the top is 3x plus 9, and then the bottom we have x minus 10 and negative x plus 30. All right, did you change that right here? We make some changes. Okay, then let's keep working. So the x minus 10 in the denominator, then no 0. So x is not equal to 10. All right, and then the next one can be a big trouble. So for ln, just like above, ln, everything inside the ln parenthesis has to be greater than 0, right? Okay, we do that. So negative x plus 30 has to be greater than 0. Subtract 30 on both sides. And then x must be less than 30, right? Since you divide both sides by negative 1. This is absolutely correct. But here is the mistake that people make. People will just think, all right, we just got all the restrictions, but there is still one. Do you see what the problem is? So I should put that in a different color. That one is, you have to also know that ln1 is equals to 0. Can we have a 0 in the denominator? The answer is no. So that's why negative x plus 30 has another restriction which is not equal to 1. Because once that equals to 1, you have an ln1 in the denominator. So this is what people usually forget. Solve this. Negative x not equal to 1 minus 30. And then x cannot be equal to 29, right? So there are 4 restrictions. So 1, 2, 3, and 4. You have to put all 4 restrictions on the same number line. So let's return to purple. So let's do the number line. We have, what do we have? We have the smallest one is negative 3, and then we have 10, and then we have 29, and then you have 30. So no 10, no 29, greater than or equal to, so we have to use a solid circle, so we shoot an arrow to this side, right? But less than 30 is here. So this is what we have. Okay, so interval from negative 3 to 10, and then from 10 to 29, and then from 29 to 30. So that's it. So again, why do we use a square bracket? Because x can be equal to negative 3. So when x is equals to negative 3, everything works fine. So that's why we use a solid circle. The solid circle in interval is a square bracket. All right, so that is the end of this video. If you think my instruction is helpful, share the video for me, give me a like, click the subscribe button if you're on your way out. I will catch you all in the next lesson.